Go ahead.
Oh, never mind.
So this is the cell Q, and then our shear flow is this one. This is sorry. So for this one, this is cell 2, and here that is a shear flow. This is Q2, and this one is Q2. And how about this one? This one is the common one. Q1, Q2 minus Q1. And then how about this one? Q2 minus Q3. And then here, we can try to directly write down the equation here. So 2G times AQ, AQ is 600 times 10 to the minus 6 times beta. So we starting from this segment and go counterclockwise. Yes.
Shouldn't that be 4G instead of 2G?
Say that again.
Shouldn't that be a 4 instead of a 2?
2. Should be 2, and that has been derived when you took a nap.
Yeah. Oh, thank you.
Don't laugh. As I was saying,
Yeah.
never mind. Okay, we'll start from here. So again, we take out this template. Shear flow Q2 divided by thickness. The thickness is how much? T1. T1 is 0.003. And multiply with length. The length is A, is 0.02. And now we go to the upper portion. This portion is Q2 divided by the same thing, the thickness T1, and then multiply with length 0.0. How much is required? That one is 50 minus 0.2, so the top one is at the length 30. And then we continue on the left side, so that is Q2 minus Q1. And then divide by thickness, the same thing, 0.003, and the length is 0.02, and then plus the bottom one is Q2 minus Q3, and divide by thickness. The thickness at the bottom here, that is T2. T2 is 0.2 millimeter, and the length is 30. So this is equation 3. Okay, so this is for the cell 2. For the cell 3, you can repeat the same thing. Let me directly write it down here. So that's a 2G times 2000 times 2 to the 6 beta. And this leave for your exercise. I directly write it down this the line here. Okay, so Q2.
How do you know the length of
All the dimensions referred to here.
Oh, wait, yeah. Never mind, I'm looking.
So that is on your handout.
Yes.
Did you
Okay.
mean Q3?
Did you mean Q3 on the first one?
On the first one? No, the first one.
Q2, Q2, Q1, Q2, Q2. Huh?
That's for number 3, right?
So then
This is for number 3. This is for cell number 3.
So why is it Q2 by itself on the top?
Q3 over.
Should be Q3.
Oh, yes.
yeah, I think all the two should be 3. And that last Q3 should be Q1.
Yes. So that should be Q3, right?
Yeah.
Q2. Q3 is here. Okay, we look at this carefully. So for this one, here, so Q3 is shear flow like this. So here is Q3, and here is Q3, and here is Q3. And from here to here, that is Q3 minus Q2. From here to here, that is Q3 minus Q1. Okay, so that means from here, seems I repeat this equation, sorry, never mind.
Yeah, you should have fixed your fuse.
Yeah, I repeat that equation, sorry, never mind. So that's on my next page. Sorry. So that is Q3 minus Q2 and 0.002. Yeah, I think the first two terms, this one is about this section here. And then the second term is about this section. The third term, you can see the whole length, 0.13, equal to this portion plus this plus this. Okay, so 4 equations and how many unknowns? We have unknowns Q1, Q2, Q3, and also one unknown is beta. Okay, and how could we solve for this one? You can put into MATLAB.
You really like MATLAB.
No, that is a convenient tool.
You gonna solve that by hand, Tara?
So here I give you the number
EES,
beta.
Wouldn't EES be like
Q
easier
point Q5.
I'd rather use MATLAB for this though.
for this?
Yeah.
Would it be easier to use MATLAB or EES on this?
I would use MATLAB.
And
Whatever you're familiar with.
Q1 equal to
Terrible at
24.62 kilometer per meter, and Q2 equal to 25.11, the same unit, and Q3 equal to 38.60, the same unit.
Can we use MATLAB on the test?
I haven't decided yet. Even I have no idea how could, I don't know. But very likely, I would very likely it shouldn't be open source, but it should be give you something prepared.